In this video, we are continuing with the interface discussion. Here we are going to talk about what are the various ways of defining interfaces. Let us see how to extend an interface. In the previous video, we have seen an interface can inherit or extend one or more interfaces. So here I am declaring an interface int1. I have some methods or properties, whatever you want, the members can be defined here. Then you have another interface called as new interface, which is inheriting the properties that are available in interface 1. This is what you call as extending an interface. So if it is class name, we call it as inheriting. One class is inheriting the properties of another class. But if it is interface, we will be calling it as extending interface. So this is an example of one interface extending another interface. You can also have multiple interfaces being extended. So I define two interfaces, interface 1 and interface 2. Interface 3 is extending interface 1 and interface 2. So two interfaces are extended by interface 3. This is also possible. Multiple interfaces being extended by an interface. This is also possible. Now when you implement interfaces, how do you do that? You specify a class. Implementing can be done only in the class. It cannot be done in an interface. So you define a class, keyword, class name, then the interface name, then the implementation part here. Definition of each and every member of interface will go here. Or you can also implement interfaces like this. Define a class name. This class can inherit one base class, only one base class. Then it can have n number of interfaces being extended. And inside the body of the class, you can define the body, or you call it as implement all the members of interface 1 as well as interface 2. Now when you see all the it is not AL, it is ALL. Let me correct it now. All the definitions in the interfaces must be defined in the class inheriting these interfaces. So if the class is inheriting this interface, if this class is inheriting these interfaces, all the definitions in the interfaces must be defined. All the declarations, let me call it, don't call it as definitions, all the declarations in the interfaces must be defined in the class which is inheriting these interfaces. Now, when you take interface, object cannot be instantiated to interface, but a reference can be created for an interface. We have already seen in the characteristics of interfaces. Interface is a reference type. You can create an interface for you can create a reference for an interface. But you cannot create an object for an interface. So you can create a reference, and the reference can point to an object of a derived class. So whichever class is extending that interface, the reference of that interface can point to the class object. I repeat, whichever class is inheriting the interface, a reference of that interface can point to the object of the deriving class. The object of a class can be typecasted to interface. This is also one important concept that you have to remember. You can have the object of a class can be typecasted to interface. So you create a reference of the interface, typecast the object to that particular interface type. That is also possible. We will see an example of it. I am defining an interface here. Two interfaces are defined, interface A and interface B, and both are having one method member declared. Now I am going to implement A and B in a class called C. So I define class C, which is having A and B interfaces inherited, and I am implementing method A1 of interface A, method B1 of interface B. Interface B1, method B1 of interface B. Now, if C is an object of class C, so what I am going to do, small c is an object created for class C. Fine. Now, I am going to create reference. Observe here, A and B are interfaces. So for the interface, I can create reference. What I do, the object of class C can be typecasted to a reference of interface. Object of class C can be typecasted to a interface. So B is actually the interface name. I typecast the class object C to an interface. Since C is inheriting both A and B, it can be typecasted to either A or it can be typecasted to B. So the references A and B can point to an object C, which is a derived class of interfaces A and B together. This is possible in C# programming. So that is what this point says here. The object of a class can be typecasted to the interface. When I say typecasted to the interface will be having a reference which will be pointing to the object of a derived class. That is what we have seen here. C is inheriting A and B, and this object is typecasted to the interface. So these references will be pointing to the object of the derived class. Which is the derived class here? C is the derived class. It is deriving the properties of interfaces A and B, or it is implementing the properties of A and B. And another very important thing here you have to remember in the interface and inheritance. Assume that a base class of a derived class implements an interface. Base class of a derived class implements an interface. Let us take this example. A is an interface, B is a class that is inheriting A, and C is another class that is inheriting B. So when I say assume that base class of a derived class, which is the base class here? B is the base class. Which is the derived class? C is the derived class. So base class of the derived class implements an interface. So whatever interface members are there, they are all implemented in B. If so, when an object of a derived class is typecasted, what do you have here? Derived class is C. So object of a derived class. I am creating a derived class object. It is typecasted to the interface. What is the interface we have? The interface is A. So I am typecasting the object of the derived class. Base class is B, derived class is C, and the interface is A. This is the base class, this is the derived class, and this is the interface. So I am creating the object of a derived class and I am typecasting it to the interface. If so, the inheritance hierarchy is searched until it finds a class that implements the interface directly. So what it will do? The reference here, the interface reference, will be searching the inheritance hierarchy. What is the inheritance hierarchy here? A, B, C. This is the inheritance hierarchy here. So it will be searched. Until when it will be searched, it finds a class that implements the interface directly. Until it finds a class that implements the interface directly. So here in this hierarchy, when you typecast C to A, it will be searching in the hierarchy until it finds a class that is directly implementing the interface. So suppose, say for example, in between B and C, I have another class here. In between B and C, I have another class here. So what the typecasting will do? It will search back to D, then it will go back to B, because B is the one which has directly implemented the interface. So it will be searching for the hierarchy until it finds a class that implements the interface directly. This is one of the important properties that you have to remember for the interface and inheritance. Let us see an example here. For the above concept, what we discussed here, for this particular concept, we are going to see an example. Take this example. This example is already available in the prescribed textbook, Balagurusami's textbook. I am declaring an interface. This is similar to your A. I have a print method. This is B. A and this is B. This is a class which is implementing the interface. It is implementing this interface. And you have derived class. This is something similar to your C. Then you are going to use new method for D. Now what you do? You are going to create an object of D. You are creating an object of a derived class. Then you invoke the print method. But here in the next statement, you are creating a reference. You are creating a reference of the interface and you typecast the derived class object. D is the derived class object which is typecasted to the interface. Then using that reference, you are going to invoke the print method. So what do you think here? Which print method will be invoked? Whether it will be invoking this print method or this print method, which will be invoked? The interface reference is now pointing to this particular object. By the time when you invoke the print method, what it has to do? It will be searching the hierarchy until it finds the class that implements the interface directly. So what it is going to do? It will be invoking the base display method. Let us see what is the output. See output here. When I invoke this print method, it is invoking this print method and it says derived display. But when I invoke here the print method, this is a reference of the interface. So it goes to the base method, the class which is directly implementing the interface. So directly implementing the interface is this print method. So it will be displaying base display. So what happens here? You can note this dot print calls the method print in the base class B, but not the one available in the derived class itself. This is because the derived class does not implement the interface. It is not implementing the interface directly. That is, the use of modifier new in the derived class hides the print method implemented in the base class. So this is what you have to understand in the case of interfaces and inheritance. How interfaces, when you are going to extend the interface in the class or in another interface, what is the inheritance property being taken care? That is what is described in this particular example. This is a very good example that you can deal with for understanding how the interface reference can be used to point to a derived class object. Next we are going to see a demo program that uses a template, that uses a C# template and interface implementation. Let us go to the example. This is the program. Observe the program. You are declaring an interface and observe here the interface is using the template. So when I use a template, any type of the object can be passed here. It can be part of any object. And I am going to have a equals method, and where I am passing the type of interface template object that you are going to bind, that will be passed as an argument here. Now I am going to declare a class which is going to inherit this. So by the time what I do, whatever object I am creating here, that kind of object I am passing it in the template. Observe here, this is a template, and for that template I am passing the car class. Then in the car class I am defining 3 data members, and then I am defining 3 properties, make, model and year, for handling these 3 values. Then what is the interface method I am having? Equals method. So I am having equals method, and whatever here you are going to have in the template, that will be passed as an object, passed as a parameter object, and so I am passing a car. Then I check whether the make, model and year are equal. If so, I am returning true, otherwise I am returning false. This is how I am implementing the equals method. Suppose, say for example, if you are going to have an array here, integer array, then you can have it as an integer array and you can pass the integer array object. So it is up to you, whatever class you are defining here, that can be taken as a template object here. Template definition. Okay, so in the main program, let us see how we are making use of all these things in the main program. So in the main program, I am declaring 3 car objects, C, C1 and C2. The first 2 are same, whereas the third one is having a model different. And what I do here, I check whether the object C is equal to C1. Again I check whether object C2 is equal to C1. So here C and C1 are equal, whereas C1 and C2 are not equal. So let us see how this program is getting executed. Let me increase the size. Yeah, so let me open the program. This is the program we have seen. I am going to execute this program. So for C and C1, it must give me, there is no error in the compilation. C and C1 are equal, whereas C1 and C2 are not equal. So it says C and C1 are same, but C2 and C1 are not same. Go back to the program again. you define the interface, extend the interface. Here you implement the interface method, then create the objects, then you just invoke the method which is given in your car class as implemented for the interface method. So this is a demo program where you can make use of templates also. You can try templates in the interfaces. Not only interfaces, you can have templates in any way, because most of the object oriented programming right from C++, Java and your C#, defining templates is very important. So you define an abstract concept of a class with some kind of template, and the template can take any object at a particular instance. That is the advantage here. Okay, so I think we can stop here for this video. Let us stop here, and we will be discussing more on interfaces in the next video.